So, and this is the result I got when I tilted my board first in the positive y direction and later in the negative y direction. Okay, so as shown in the video. All right, great. So you can try all those things at your desk and try to get the graph and analyze the behavior, okay, of the readings whenever you move your sensor. Okay, so you will understand how exactly the sensor is behaving when you change the orientation of the boards. Okay, great. So now let's continue our discussion about calculating the tilt angle of our board or any object, okay, by using the MPU 6050 sensor. So the formula is this one. So let's say if you want to measure the tilt angle on y-axis, then so you have to take sine inverse of y divided by square root of y square plus z square. Okay, so actually you have to take the square root of y square plus z square plus x square. Okay, you have to take all three components, but x is 0. Okay, so that's why I just omitted that. Okay, so actually you have to take the resultant vector of x, y and z, and the way to take that is actually square root of x square plus y square plus z square, right? So this is from your basic trigonometry, and if you want to know the tilt angle on x-axis, then you have to replace y by x, right? Okay, and you have to take sine inverse of that. Okay, so now let's experiment. So here I have tilted my board by resting it on a small object. Okay, and if I measure the angle with respect to the surface of the table, it is around 12 degree. Okay, let's see whether we can able to derive this value experimentally. Okay, great. So now I have my application ready, so you need not to change anything. So now let me run this program, and my program is actually emitting the x, y and z components. Okay, so now let me stop it, and let me just copy all these values, okay, to a notepad. Okay, so and if I see here, I can see that I have got so this is the y-axis, right? So this is the y-axis, okay, and this is the z-axis. Okay, so we are not interested in x-axis because this is the tilt over y-axis, isn't it? Okay, so now I will consider y value as 0.20 and the z value as 0.97. Okay, now let's find out the square root of y square plus z square. Okay, so for that I'll just use a Pythagorean calculator here. Okay, so we have to find out the square root of a square plus b square. In this, a is y and b is z, right? So I'll just say find the value of c, and okay, I'll just give 0.2 and 0.97. okay, all right, so now just calculate the square root. Okay, this turns out to be 0.9904. So what do you have to do now? Y divided by 0.99. So now I have a arc sine calculator. So this is the inverse sine calculator, and here I will just write 0.2 divided by, okay, so it won't take divided by. All right, so now we have to calculate that manually. So y divided by, y is 0.2 divided by this number, right? Let's copy this and paste here. Okay, equal to, it is equal to 0.2019. so let's write 0.2019. okay, hit calculate, and here it is. It is approximately equal to 12. Okay, so my protractor is actually showing 12. Okay, so but experimentally we got 11.6, which is very close to 12 degree. So the answer we got from the experiment is very close to what we measured using the protractor. Okay, so now let's again try once again. Okay, so let me again raise this angle. All right, so now I have increased the inclination, okay, of my sensor to the surface. So now the protractor is showing 33 degrees. Okay, so now let's run our program once again, and all right, so now let me take this final value here. Okay, 5,4 and 8,2. so let's calculate the square root of that. 5,4 and z is 9882. Okay, calculate, and it is 9818. So now let's calculate the value by dividing the y-axis by this value. Okay, 9818. Okay, so that turns out to be 50. Okay, 54 divided by 0.9818. Okay, and that turns out to be 5500. Okay, 0.550010. Okay, so now let's calculate, and this experiment says that it is around 33.3 degrees. Okay, so my protractor actually showed it as 33 degrees. Okay, that's approximately matches. That's how you can measure the tilt angle of any device by using the accelerometer. Okay, so now if I put this device to 90 degrees, okay, so let's see what happens. Okay, so now I have placed my sensor to 90 degrees. Okay, so this is exactly 90 degrees now. Okay, and let's see what my sensor is reading now. The x-axis is already parallel to the ground, but the z-axis, which was perpendicular to the surface, okay, when the sensor was at rest, now went parallel to the surface, right? So that's why you are seeing zero values in the z-axis. Okay, but now the y-axis has become perpendicular to the surface. That's why you are seeing 1g of acceleration at the y-axis. Now if you measure the angle by taking these values, then it must show 90 degrees, right? So you can try that. Okay, so let's put 98 here. Okay, and let's put 0.01 here. Okay, that turns out to be approximately 9801. So 0.98 divided by 0.9801, that's approximately equal to 1. So what is sine inverse of 1? The sine inverse of 1 is 90 degrees, right? Okay, so now let's see what happens when I keep my sensor upside down. Okay, so now I have kept my sensor upside down, and here you can see that both x, y and z are showing the negative values. Okay, so observe the z axis. Okay, so z axis is actually showing -1g, so that indicates that the sensor is upside down.